In this video, what we want to do is, so we've already discovered, so programs tend to have a lot of data. So the first thing, and perhaps the simplest thing to talk, so this example of a list uses players from the Toronto Blue Jays Major League Baseball team, and so I've created a list with 2 players in it, and I've called it the list players. So I'm going to use players to refer to this list from now on. So what does it look like? If I was to print after each of these lines, let's say I printed out the content of my list called players, what would I have? Well, I have 2 names inside. I know they're text because I've used double quotes, and it's just going to print me out the first name, Bo Bichette, the next name, Cavan Biggio. But what if actually I want to add more players to that list, right? A team isn't just 2 people. So I can say players.append, and then inside my brackets, I can add a new name. So if I print it out after that, we now have a 3rd player. We've added Brandon Belt onto the end. But remember that these are in order, and I can set them to be a specific order. So I might want to insert something at a specific place. So let's say I want to put the name Danny Jansen at the start of my list. So here what I'm doing is, I'm saying insert, rather than append onto the end, insert something. Insert me something at position 0. Remember, position 0 is the first one in the list. And put this inside position 0. So now, Bo Bichette moved from position 0 to position 1 because I've got a new position 0, which is Danny Jansen. And then in the same way that I add things, I can take them away. So I might want to take something away. So what happens if I just say .pop, just pop something off my list? Well, it takes the thing at the very start of the list. So every time it pops something off, it's the thing at position 0 that goes away. I might not always want to take position 0 away though. I might want to remove someone that I know is in a specific index or position in the list. So in that case, rather than having empty brackets, I can put an index inside. So I have 3 names on my list. That's now index 0, 1 and 2. Because those indexes are updating every time things are added or taken away. Position 1 is Cavan. So I'm going to take him away. And I'm left with now 2 players on the list. A tuple is exactly the same. We can do the same kind of access where we can, each thing has an index. But what's different is that a tuple is unchangeable. So I can't go adding things to it or taking things away. All I can do is define it at the very beginning, declare what I want inside, and then I can access things at a given index or a given position. So this is really useful when I want data that doesn't change. So I can't change it by accident in my program. That might be something like historical data. The list of kings and queens isn't going to change. That's factual. It might be mathematical constants that just don't change. For example, pi will always be the same number regardless. And the way that I say that something is a tuple is that I use round brackets. So if I try and insert something, append something, delete something, I'm going to get an error message. It will say you can't change a tuple. So all I can do is define it like this. A set, then, is again like a list, but this time there isn't an index. So it's not ordered in the same way that a list is ordered. So the way that things are presented, if I was to print this out, the way that things are presented depends on the Python interpreter. So it might seem like if I was to create a list and print it out, it might seem random, but it's not. It will be different depending on which interpreter you use. So for Colab, it will always be the same. But if I went and tried to use Visual Studio, for example, another development environment, it would be different. So this is the key thing to remember, is that it appears random, but it is not. And I set that up using curly brackets. So I've created here a set. I've got 7 characters. I've placed them inside some curly brackets to say this is a set. It's a collection of information, and it doesn't matter which order it's in. That order will be determined by the interpreter. So if I was to print out this set into the console, the order that it presents here is A, F, G, C, B, E, D. That may be true for one interpreter, like Colab, but if I then go and run my same code in Visual Basic, for example, that order of presentation may be entirely different. So that's important to remember. Because when I ask it to pop something, to take it away, it will take away the first thing, right? So it always takes away the thing at position 0, but what I don't know is what is in position 0. That's going to be inconsistent across different interpreters. In this case, what's at position 0 is A. So if I take that away, I now start F, G, C. But that's not going to work because I don't always know what is currently at position 0. So the way that you can remove things is by removing by value. So if I want to remove D, for example, the letter D, I can say dot remove and then the D character. And then regardless of where it is positioned, regardless of which interpreter I'm using, it will always remove the value D. And so in this case, D is at the very end, and so all that will happen is the end will simply be taken away. A dictionary then, this is the most complex presentation of data. It's extremely useful because it allows me to give more meaning to things, but it's slightly more complicated. So what happens in a dictionary? It's used to store values in key value pairs. So what that means is that I have a name, which is an identifier, and then a value, which is the data it relates to. So back to our baseball player example, I have a player called Brandon Belt. So my name is my identifier, that's my key. I want to refer to this, label it just as a text, just as a string of characters. That's how I'm going to identify it. And so I'm going to put name. I might have DOB for date of birth, height, weight, etc. And then I have, to go along with each of those, some data. So to go with name, I have the player's name, Brandon Belt. For DOB, I have their date of birth expressed as a string. There are various ways we can do this. I can't do much manipulation on it if it's a string, but I can pull out the data. Height, however, I've expressed that as a float, as a number. Same with weight. So you can see that some things I've put inside double quotes because I want them to be a string. Some things are just as a number because that's what I want to manipulate it as later. A key and a value is separated by a colon, and then each of my key value pairs is separated by a comma. So that's the same thing that we've seen before, where we have a bunch of items in some kind of structure, with a comma between them, my dictionary gets a name, and everything in my dictionary has curly brackets to separate them. Or not to separate them, to group them. There are two ways that I can access and update my data, and both are equally fine to use. So I might have my version of runs. So I want to get the data. So inside this new variable called runs, I want to make runs become something. I want runs to become the value inside player, and then the key HR_2021. So that's home runs for 2021. We had defined that as a key, and it has a value associated with it. So the value that's associated with it will go here, and that will become the value of runs. I can then do it a different way if I want to. I can use .get. So rather than put in square brackets my key, I can put .get round brackets my key. The same thing will happen. Player.get HR_2021 will be replaced with a number, which will then be put into the runs variable. So that's getting data out. What if I want to put data into my dictionary? What if I want to update the data? So it's during the 2021 season, my player has got additional home runs. I want to update information I hold. So this is my variable essentially. This is my player key. So whatever is inside player at that key, make it become 29. And I've put it in as text. So it started off as a number. I can put it in as text later if I want to. Probably not a sensible idea given that it is a number, but just to show you that it's possible to change the type of a variable through this update method. I might want to do it another way. I might want to say player.update, and then this one, note we've got a round bracket and then a curly bracket, and inside there I have my key, colon, and what I want it to become. So that's a bit more like how we saw it being defined. But there are two ways to do it. One through using a function or a method, and one through direct manipulation. It doesn't matter which way you do it, either is fine for the purposes of this program. So I am aware that that was a reasonable amount of information to take in. There's a lot of things to compare or remember that are different between the two. So there is a file called Data Structures Comparison Table. What I would like you to do is download that table and create your own aide-memoir of how each of these things functions. So we looked at a list, a tuple, a set, and a dictionary. So if you download a copy of the file, fill it in with the code, any notes that you want to take to explain how it works, something that will help you remember later, and then some example code, so that if later I come along and say, how do you create a list, you have an example ready to go. Or you decide, oh, I have all this data, I want to store it as a set. You have an example of how to do that, and you can replace that, put your own data in. So something to help your life later on, something to make life simple, but download that, fill it in, take any notes you need to, and that will be extremely useful as we go forward.